Hello and welcome to Lesson 1 of our Python track, Absolute Basics of Python. I'm Rishi, one of the heads of programming on Cardinalbotics. Today, we'll learn about expressions, operators, data types, variables, and writing a Python program. You will have to learn some basic programming concepts before you can do anything. Like a wizard in training, you might think these concepts seem arcane and tedious, but with some knowledge and practice, you'll be able to command your computer like a magic wand and perform incredible feats. This lesson has a few examples which I'll encourage you to type into your own interactive shell, also called the REPL, which I'll show you in a second. Using the interactive shell is great for learning what basic Python instructions do, so please give it a try and follow along on your own computer. You'll remember the things you do much better than the things you only watch. We set up mu in lesson 0, and I just mentioned the interactive shell. To open the interactive shell, click this REPL button right here, and then drag this up if it's a little too small. I'll show you an example of what you can do with the interactive shell. You can do simple math in Python, like 2 plus 2. In Python, 2 plus 2 is called an expression, which is the most basic kind of programming instruction in the entire language. You can try typing more complicated expressions. Here's an example. Once I hit enter, Python will evaluate the result. Let's take a closer look at what Python just did. So this is the expression that we just put into our shell. And if we take a closer look at each of the components, these are the operators, and these are the values. Operators are like operators in math. All the standard mathematical operators can be found in Python, like addition, subtraction. In our previous expression, we used both multiplication and addition. It's important to note that Python does follow the order of operations. So taking that into account, this first line first evaluates 3 times 6 because of order of operations, and then adds 2. So 18 plus 2 is 20. However, this line, because of the parentheses, 2 plus 3 is evaluated first, which is 5, and then 5 times 6 is 30. To break it down more graphically, this is our original expression. The 2 times 3 was evaluated first, which yielded 6. And then once we add 2 plus 6, we get 8. Here's a slightly more complex example, but it's the same idea. An important concept in Python and all programming languages is syntax. Syntax is to Python as grammar is to English. If we look at these 2 lines of English, this is a grammatically correct English sentence, and this grammatically is sentence not English correct A. The second line is difficult to quote-unquote parse because it doesn't follow the rules of English. Similarly, if you enter a bad Python instruction, Python won't be able to understand it and will display a syntax error message. So here, 5 plus, that doesn't make sense. Like if you try to input this into your calculator will throw an error. Just like that, Python complains that it's not correct syntax. Side note, errors are okay. And the last slide we saw a syntax error. There are lots of errors in Python. You can always test to see whether an instruction works by entering it into the interactive shell. Don't worry about breaking your computer. The worst that could happen is that Python responds with an error message. Professional software developers get error messages while writing code all the time. Remember that expressions are just values combined with operators, and they always evaluate down to a single value. In our previous example, all our values were numbers, more specifically integers, which is the data type in Python. Here's a table of the most common data types in Python. The values -2 and 30, for example, are set to be integer values. All values belong to exactly one data type. Integers are whole numbers. Floating point numbers have a decimal place. Python programs can also have text values called strings, which are surrounded by single quotes so Python knows where the string begins and ends. So we have integers, also known as ints, floating points, also known as floats, strings, which are sometimes called strs. Again, the integer or int type indicates that the value is a whole number. The floating point or float type number has a decimal place, and text values are called strings. Strings have lots of interesting properties. The reason they're called strings is because they're strings of characters, as shown here. Sometimes the meaning of an operator may change based on the data types of the values next to it. For example, the plus sign is the addition operator when it operates on two integers or floating point values, or ints and floats. However, when the addition sign is used on two string values, as it is here, it joins the strings as the string concatenation operator. So if we come back to the interactive shell, we can play around with strings a little bit. We can add strings, and Python will tell us the output. We can also try multiplying strings, which is kind of interesting. Finally, here's what happens if you forget to close your string. Variables. What are variables? In computer programming, a variable is like a box in the computer's memory where you can store a single value. So here, we're assigning a variable named spam the integer value 42. I'll show you how to do that in my interactive shell here. So keep in mind the box analogy. We had a box called spam, a variable called spam, and we gave it the value 42. And now we can see if Python actually remembers this value, and it does. We can do lots of things with this variable that we have. We can create more variables. We can add variables. We can add lots of variables. And we can even change the value of variables. So a variable is initialized or created the first time a value is stored in it. So here we initialized spam and we initialized eggs. After you initialize a variable, you can use it in expressions with other variables and values. That's what we did here. This is also technically an expression. When a variable is assigned a new value, as we did here, the old value is forgotten. So initially, spam was containing the value 42, but we added 2 to it. So now it should be 44. This is called overwriting the variable. Variables can be set to any data type. I use integers in this example, but you could easily use strings. And I could put my last name here, and then add them together to get my name. Try playing around with some variables in your own interactive shell. I mentioned overwriting variables. Here's the box analogy used on overwriting variables. With the box analogy, the spam variable of this example stores hello until you give it the value goodbye. Side note, but an important side note, you should always give your variables a descriptive name. For example, say you are trying to write a program for a banking account. You'd want to name the variable that stores the amount of money you have appropriately, like current balance. Though you can name your variables almost anything, Python has naming restrictions. You can name a variable anything as long as it obeys the following 3 rules. It can only be one word and have no spaces. They can only use letters, numbers, and underscores, which is this symbol here. And it cannot begin with a number. Alright, why don't we try writing our very first Python program? While the interactive shell is good for running Python instructions one at a time, to write entire Python programs, you'll type the instructions into the file editor. The file editor is similar to text editors such as Notepad, Google Docs, Microsoft Word, but it has some features specifically for entering source code. Now, if you had the interactive shell open, the file editor is the text up here. So you can go ahead and close that. For now, follow along in your own editor. After we run the program, I'll explain it line by line. Alright, make sure that it's saved if you don't want to lose your work, and make sure that you've copied it properly. To see if you've made a mistake, hit run. If you've made an error, you should get an error message here. I'll show you one as an example. Say I forgot this parentheses here. It'll tell me what line the error is on, and it might even tell me what the error is. If you can't figure it out, just check it against my own code and see what you've done wrong. It's helpful to type out this yourself as it can aid in understanding. Let's see what happens when you run this file. So we're prompted with, "Hello world, what is your name?" And it's asking us to input our name, so I'll put my name. It is good to meet you. The length of your name is 5. Let's count. 1, 2, 3, 4, 5. Seems right to me. What is my age? My age, I'm 17 at the time of this recording. It tells me I'll be 18 in 1 year. Alright, so what exactly is going on in this program? Let's break this down line by line. So on this first line here, this is called a comment. Python ignores comments, and you can use them to write notes or to remind yourself of what the code is trying to do. So for example, I could put like, "I like both dogs and cats." And this won't change the runtime of the program. It won't change how the program runs at all. So Rishi, 17. As you can see, it's the exact same output. Python ignores comments, and you can use them to write notes or remind yourself of what the code is trying to do. Any text for the rest of the line following a hash mark, which is this symbol here, is part of a comment. The print function that we use in the next line displays the string value inside its parentheses on the screen. Now what does that mean? Well, in our file, when we click run, the text "Hello world" and "What is your name" is printed to the screen. And those are the string values that we put inside here. This line, if you were to read it in plain English, means print out the text in the string "Hello world." When Python executes this line, you can say that Python is calling the print function, and the string value is being passed to that function. A value that is passed to a function call is called an argument. Notice that the quotes are not being printed to the screen. They just mark where the string begins and ends and are not part of the string value. We can explore this further with the REPL prompt. So if I type print, and let's say I type my name, the string value is Rishi. And it is an argument being passed to the print function. Once I hit enter, it'll just tell me Rishi. But I could also do stuff like, so now I've stored the value, the string value Rishi, into the variable my name. If I print the variable my name, then I'll get my string value out. Now this might be fairly obvious, but it's good to get the basics out of the way. The next line is input. So the input function waits for the user to type some text on the keyboard and press enter. The function call evaluates to a string equal to the user's text, and this particular lines of code assigns that string to the variable myName. You can think of the input function call as an expression that evaluates to whatever the string the user typed in. If the user entered Rishi, then the expression would evaluate to myName equals Rishi. Or if the user entered Kai, then the expression would evaluate to myName equals Kai. We can see that here in, let's say I want number equals input. And then notice it doesn't automatically go to the next line. This is because it's waiting for me to put in something. So I can put 8. And then if we check the value of number, it's put in there. Or if we say, I don't know, word. The variable name doesn't really matter here. Banana. And we say, what is the value of word? Banana. This next print line has something we haven't seen yet. The following call print actually contains an expression. The expression, it is good to meet you, plus my name. Remember that expressions can always evaluate to a single value. If Rishi is the value stored in my name, then this expression evaluates to, it is good to meet you, Rishi. This single string value is then passed to print, which just prints it on the screen. Next, the len function. You can pass the len or length function a string value or a variable containing a string value, and the function evaluates to the integer value of the number of characters in that string. You can try this out in your own shell. So I could say, what is length of tower? Now the word tower, if we counted ourselves, has 1, 2, 3, 4, 5 characters, and Python agrees with us. And you could also do a very long thing, like twinkle, twinkle, little star. And I'm not going to count that, but apparently it has 27 characters. Just like in these examples, length myName, len myName, evaluates to an integer. It is then passed to print onto the screen. The print function allows you to pass it either integer values or string values. While these two lines are pretty basic, and we've pretty much covered them already, this line is a little bit complicated. Here we use two new functions that we haven't seen yet, int and str, or string. If you want to concatenate an integer, such as 29, with the string to pass to print, you'll need to get the string value 29. What I mean by this is, say, if we print 29 regularly, there's no problem. But if we want to concatenate, if we want to add it to a string, I'll say Bob, we're going to get an error. It's telling us we can't add an int to a string. What we can do is instead we can use the string function. So let's take print, we had print 29 plus Bob. We can't add an integer to a string value, but we can concatenate two string values. So to turn this into a string value, we can say str of 29. And there we go, it works. Equivalently, the int value turns a string into an int. So if we had 2 plus 2, this doesn't work. But if I did print 2 plus int 2, then this would work. Obviously, print 2 plus 2 just regularly would work as well. But I'm just trying to show you how the int and the string function work. So in this case, the input function gives my age the string value 17 because I'm 17 years old. So we can say that this is 17 for our example. However, we want to know how old I will be in a year, and to do that we have to do some math. So we temporarily turn it into an int. So this turns into 17, the integer. We add 1 to it, it turns into 8. But now we want to use it in a string, in a sentence. So we have to turn it back into a string using the string function, and this will turn it into 8. And what I just did there, those are the steps that Python will do for you behind the scenes. That's what this code accomplishes. So to summarize, today we learned about the data types, the first of which is the integer or the int, which is like 1, 3, 5, 17, 30, all the whole numbers. It includes negative numbers too, like -5. The float or the floating point number, which are all numbers which are decimals. So 2.4, 3.14159, 6.8, 5.0 counts as a float. And finally, we learned about strings, which are strings of characters, Python's way of inputting text. Bob, 1, 2, 3, hello, as long as the single quotes are on both sides. We learned about operators, plus, minus, times, divide. We also learned that you can use plus and times for string operations. We learned about the print and the input functions, which handle simple text output and input, respectively. We learned that the length function can take a string and evaluates to an integer number of the characters in the string. It evaluates to the length of the string. And finally, the str or the string, int, and float functions will evaluate to the string, integer, or floating point number form of the value they are passed. So if int was passed the string value 27, like 27 between quotes, it will return 27. It will evaluate to the integer 27. Remember, if anything is confusing you, you can always try stuff out in the interactive shell. Finally, this week's practice programming problem. Here's my challenge for you. Write a program that asks the user for an integer and then prints the integer that comes after that. Here's an example of what the output could look like. The program asks me to enter an integer. I give it 5. It tells me the next integer is 6. I could also give it a large integer like 18,792, and it'll be able to tell me the next integer is 18,793. If you're feeling very lost and you do better with a written guide, check the description for a link to the slides and also the textbook chapter. Thanks for watching.